So today we're going to be learning about composition of functions. That's where you plug in one function into another. Now, do not read this as f times g. This is not multiplication. The way you would read this would be f of g of x. So this is f of g of x. This would be g of f of x. In other words, what you're doing is you're plugging one function to another. Another way to write this is f with g of x as its input in parentheses. So f of g of x or g of f of x. So what we'll be doing here is whatever's in the middle, like here g in the inside, that's what you plug into the other function. So you're plugging one function into another. So here we would be plugging g into f. For this one, we would plug f into g. So our first examples, we're going to be finding f of g of x. So g goes on the inside. So the way I'm going to set this up is I'm going to leave f on the outside, and then I'm going to plug in whatever g of x is. So here g of x is x squared minus 1. So I'm just plugging in the value for it. That means we're really going to be using function f, but we're going to be replacing x with the x squared minus 1. I like to write it out first. So f is 3x minus 4. But for x, I'm going to put a blank parentheses. So f is 3x minus 4. But instead of x, we're plugging in x squared minus 1. And now we can work it out. So I'm going to distribute. So I get 3x squared minus 3 minus 4. And if I combine like terms, it's 3x squared minus 7. If we look at problem B, we're doing f of g of x again. So I'm just going to rewrite it as f with g of x on the inside. So I'm going to start by plugging in g. So here g is 2x plus 3. So that goes in my brackets or parentheses. So I inputted g, and now I'm going to write function f, which is 3x squared minus 2x plus 1. Everywhere I see an x, I'm going to put an empty parentheses. So f is 3x squared minus 2x plus 1. And then in my empty parentheses, I'm going to plug in my input, which is now 2x plus 3. So it's like we plugged in g into all the x's in f. Here, remember we can't just distribute that 2 because of the plus sign. So I'm going to expand 2x plus 3 squared. Now I'm going to work this out from left to right. So 3 times 2x is 6x. 3 times 3 is 9. That becomes its own parentheses. Now I can distribute these two. This becomes 12x squared plus 18x plus 18x plus 27 minus 4x minus 6 plus 1. So right now I just did the multiplication. Now I can combine like terms, so 12x squared stays the same. If I combine my x's, 18 and 18 is 36, minus 4 would be 32x. And now if I combine my constants, 27 minus 6 is 21, plus 1 is positive 22. Next, we're going to be doing the same type of problems, but we're going to be doing them for g of f. So same process, is just now g is going to come first. So g is on the outside, and f of x is going to be our input. So I'm going to start by plugging in f of x, which is x minus 5. And now I'm going to write function g. So 4x squared minus 1. But for every x, I leave an empty parenthesis. And then I can input the x minus 5 into that parentheses. So it's like we plugged f into g. So x minus 5 got plugged into the x for g. Now I'm going to expand my squared. And then I can multiply from left to right. So 4x minus 20 becomes its new parentheses. And I'll continue to distribute now. So 4x times x is 4x squared. 4x times negative 5 is negative 20x. Then we get another negative 20x. Negative 20 times negative 5 is 100. And I'll bring down the minus 1. So now we combine like terms. I have 4x squared. Negative 20 and negative 20 is negative 40x. And 100 minus 1 is 99. We're going to do one last problem here. Again, we're doing g of f for these problems. So g goes on the outside, f of x goes on the inside. So I'll start by plugging in f of x, which is negative 4x. Now I'm going to write g, which is 5x squared, but I'm going to leave an empty parentheses where I have x so that I can input the negative 4x. So it's like we plugged in negative 4x to the x in g. We're plugging f into g. Here, since this one doesn't have a plus or minus, you can actually just distribute the 2. So 5, negative 4 squared is 16, and x squared is x squared. If you were to expand it like we did on the other problems, you would get the same thing, because negative 4 times negative 4 is 16, and x times x is x squared. But because this one didn't have a plus or minus, you could do the shortcut. Now 5 times 16 is 80. So our problem is 80x squared.